Howdy. Howdy there. What you doing down there? I know that's real stupid. I just don't know how to talk to a camera. A dirty, dirty little camera. Oh, you're so dirty. Okay, that's not good either, is it? Kind of going on the design phase, the design theory here. I have decided that what I want is I want to make a straight piece all the way across here, which is this piece. So that's 3/4 of an inch tall through here. I'm going to try something with that and try to keep it separate from this piece so I can take them apart separately, which may mean, I don't know, we'll see. Anyway, I'll try it. So if I turn this over, you can see there are some parallels. This piece is now in this channel. These little perpendicular attachments, one in there, if you can see that, and one in there, and then this end piece covered with this. So these are three, as you can see, three components. I wasn't going to originally do this, but I decided to go ahead and do this. Make this section a 3/8. This is almost a quarter. It's between 5/16. It's I don't know. 5/16 is probably a good guess. So what I did was I dropped this section down. So it is more in line with this. I raised these two edges. As you can see, I've got a piece sitting on top of here. Same here to correspond to that increase right there of thickness, and that's for where this piece seats. So that's been taken care of. And if I unattach all these screws, everything falls apart. So it may not be so evident how it works, but so far I believe that it's a pretty good form. So got my first interior piece on. This piece, you can see how it's put on. I just have it raised up. There's a nut, and then there's also a washer welded underneath, or an 1/8 inch thick washer. Same here, and a hole in the washer so I can put more of the bolt through. But there's a nut underneath there. So this is just held in place right across this little valley. The valley is the C channel that I am referring to. So you can see, maybe you can see how that works. That's lined up or centered. It may not look centered, but that's because I have this 1/8 inch piece here. There'll be another 1/8 inch piece that sits against this piece. And that'll go on, I hope, somehow. And you can see it's got a bit of a lean, probably about 10 degrees, maybe a little less. That's this piece that has a lean coming in. So the piece that I put here, which will likely be one of these guys, I've got these marked out, yeah, outside. This piece will attach somehow down here and lean inward from about 1/4 of an inch, or maybe even maybe it's 3/8, maybe about 3/8 of an inch, as you can see, to roughly 1/8 of an inch. So I've got to get that piece put in somehow, and that also partitions off, you know, this channel. So this piece would be, you know, basically doing that. So somewhere in that vein. This piece, of course, being in here. So it's a little bit further, a little tough to figure out how to do that, but it comes off quickly. And I like the idea of having these pieces split rather than having another C channel, because if I can eliminate places that are hard to take apart, it's, you know, so much the better. And I think that will work out well. You know, I do have the option of welding it in if I decide I need to. So that's something that I might consider. I'd like to give a moment of silence for, yeah, he let me down and had to die. So, a bit of silence for him. So now I'm using an impact driver, and I'm using a socket, which I cut the length off of, so these little short bolts don't get lost up in the socket. I like the fast forwarding stuff. It's kind of cool, but I think the show and tell is also good. Grinding is grinding, cutting is cutting, welding is welding. But if I can show you what I'm doing, explain why I'm doing it, which is a hard enough thing to do for me anyway, maybe that's a pretty good thing to do, and maybe help you with your project, which is kind of the idea of doing this, other than I just like looking at myself, you know, on YouTube. This C channel needs to be fashioned. Okay, here's my thinking about this. I think that designing your permanent mold, it's probably a good idea to understand that the steel mold will keep your part from shrinking a lot better than doing a sand casting. It holds it in place. But I think the aluminum still wants to shrink, so it's going to tighten up around things that it can tighten up around. If I have a C-shaped piece in here, which is what I need, which, you know, here we go. There's 2 legs of that C. If I have a 3, you know, all these, okay, side, bottom, and side, all the way across here, and then as this form cools, it's going to shrink against that, and it's going to grab it pretty tightly. It's going to make it hard to get it out of there. I experienced that with my last form, my last mold, and you may have seen that video because you're watching this video. So anyway, having done that and thinking about the design of a permanent mold, it seems to me that it would be a good idea to not allow that to happen to begin with. And so my response to that, you know, the aluminum tightening up, is to try to design the mold so the aluminum can't really tighten up, or if it does tighten up around a part, that I can at least take the rest of the form apart and then pull whatever part that is tied out, you know, worry about it separately, not tie the whole form up. You'll notice here that I've got these voids, and these voids are the same kind of a deal. Let me do this. Let me just take this piece off, and then, you know, Band-Aid. All right. What I like about this piece is that it is going to give just a little bit as the aluminum cools, but it's still probably going to hold it in shape pretty well. But if it does tighten up against this piece, it's not four-sided, it's three-sided. So these can flex a little bit if I leave them the way they are. That's nice. It's stiffest across this point right here. So I would assume that where it's going to stick would be, you know, right here. That's where it's going to be at its tightest. If I have my draft carefully taken care of, where it's really tight, I should be able to tap it out, and it should work well. What I have finished are these two pieces. This is the outside of this, and this is the outside of this. This is, we'll call that these are resonators. So these are my outer sides of the resonators. And so I measured across this point, which is usually 1 3/16, and if you look at my length here, it's just like 1 3/16. So my measurements are right, and the measurements are good here. Carefully welded, and I can take these pieces out separately. So I should be able to get this out of the form relatively easily. I finished this interior piece for the channel, and I've also adjusted these little wings. Notice these nuts, and well, bolts, nuts welded behind, nuts on top here, bolts on the bottom here. These come off, and then the central piece comes off with this bolt and this bolt. So I've taken it apart. Now I've also welded a pin through here. I drilled a hole and beveled it and welded the pin, and then I've ground that down. I haven't taken that apart yet, so I'm going to set the camera down and just see how hard it is to take this apart. Okay, not that bad. So I have a pin here, a hole, and then I have two mounting brackets. I am right now putting these little tiny pieces on. Well, I'm putting this piece in a vise, folding that edge around, cutting away where I need to fit around this, and filling all my holes up. The pressure of this corner, when me pulling it there, was tipping this center piece. So I put this top piece on to counteract that, and I'd used vice grips to pull this gap back where I wanted it. Makes a pretty tight seal, tight enough to keep the aluminum from coming out. Having it wrapped around a corner, I think is a good deal, because if it's wrapped around a corner, the aluminum has to go through this tight spot of something that's cooling it quickly, and it just has a larger surface to get around, and so I like having it around the corner. So another little stitch weld, which is really about the best you can do with these little welds on these thin pieces of metal, especially when you don't want them to move on you too badly. So, look at that. Isn't that nice? And that'll be my rail. It's funny how crappy it looks on the outside. Well, it kind of looks cool, but it's nice and clean on the inside. So, good to see. So that piece fell off nicely. So yeah, it's looking really good. I'm in the final stages, I hope, of getting this form tweaked and fit. I'm working on this piece, specifically that little spot right there. I've made it through to see that spot, this spot. These joints are just really tricky. I've covered this piece, and then there's that joint, which is pretty nice. So that joint looks good. Added a little piece here, added a little piece here. So to finish, I will make sure that this joint is good. I'll probably add some metal to it. Finish the joint that's underneath here and add a piece. This spot, need a little piece, and I need a little piece right there. Looks pretty good, same. Nice and tight. Nice and tight. So anyway, it's looking pretty darn good. The real test, I suppose, is how much light can I see? Hardly anything. Can you see that? We don't want to see much. That improved it by, I don't know, 9 out of 10. And not only that, but I found a piece of metal that's not terribly rusty. Look at that. That is some clean metal. Okay, it's a little, I don't know what the hell happened to it there. Got a piece cut. You can see there's like several different versions of the same piece because I kept messing my measurements up. But I think we're good. I'll go ahead and see about bending. You know, the annoying thing about a vise is you can usually only get one bend out of it when you're making a three-dimensional part, because once you've made one bend, the other bend always interferes somewhere down here. This one might actually work. We'll give it a try. So, got it crimped down. You can barely see that line, but you can see my cut here and here. Leaving a little draft. It's not too bad. Always difficult. Went ahead and cut my extras off and just welded them to this. Just letting that cool on that form. So hopefully when I disconnect it, it's relatively parallel. This is an extra piece I welded on. Just stitched it on. Notice there's a hole in the nut here, corresponds to that hole. So then I've just wrapped little pieces around. I don't even know what to call this thing. A filler funnel. Okay, a filler funnel. Okay, I guess that wasn't that hard. A filler funnel. So the filler funnel and this one, kind of the same deal. I really don't want the metal to be hitting that middle partition and causing turbulence. So I'm going to build, it's going to be set, well, it may be set off center, maybe not, I don't know. But I'm going to build another deflector. I think we're okay. Not going to be cutting anything with this, so. Alright, I think we're done. Rather than put a bolt on, well, been through that. Anyway, this is what we got. This is a little side, and this is the big side. They actually do correspond volume-wise to size-wise. But that's, you know, I just don't want the interference here. I want that to be a smooth flow down to the bottom, as much as I can make it. So that's going to help that. It looks pretty damn good. This one attaches pretty nice to make it work. So we're in good shape. Other than a little coating of boron nitride, this is ready to test. Form is done. I made sure that as much as possible that all the welding balls are gone. Notice this one's sprayed a little bit thicker because I think this is going to be, this is my estimation of the wand that's going to be tough to get out. It looks beautiful. Okay. So I got everything set up. All aboard camera stand. Have a couple pieces in there. It's probably been running for 10 minutes. Got it running, but I'm seeing some orange down in there, so we're probably about 10, 15, 20 minutes out. Alrighty, we're good. That's hot. It's about 790, which is way too hot to pour it. I'm going to take this opportunity to let it cool. That's 791. Got really hot. No, okay. Let's try. Much better. 738. It's cooling off pretty fast. $712, $713. Actually, kind of low. Okay, on the floor. $695. That's what I got. So I'm going to pour cooler. I'm just going to pour as fast as I possibly can. Wow, how do I do that? Just on my measurements. Oh no, I didn't. I think it's going to be a rotten pour. I think we're going to have all kinds of bad stuff going on. Alright, here we go. So I'm taking it apart. No, cold all the way through here. Yeah, I know I poured. I poured it cold because I got in a hurry. I should have heated it back up. The metal was cooling, and I just decided, oh, it'll probably pour okay at 690, but 725 is where I should have poured it. Look at that. Other than that problem right there, this is good casting. I can fix everything that happened here with a little more temperature and a little more attention to speed. So, all right, that's a good one. We're gonna stop now and okay.